So today we are going to learn about electric motor. Okay, and we studied about the Fleming rule. Okay, we studied about this rule of Fleming, and in this rule, I taught you this thing that how this conductor will work. So it was our magnet, and you can see it is our rod, aluminum rod. So in this case, we have to generate uh, force. Okay, two things are provided to you. I collected this diagram for somewhere and just want to tell you that one time the direction of current will be like this, and another time the direction of current will be like this. Okay, and one time the this aluminum rod will move towards this side, and another time this aluminum rod will move to this side. One time it go to south, near south pole, and another time it will move to North Pole. So today we are going to learn about motor, and we will do these questions if we have some time left. So electric motor is something. This is the diagram of electric motor. Okay, this is the diagram for and from NCRT. But remember one thing, that this is not the accurate or correct diagram. Remember this, that this is not a accurate diagram or correct diagram. Okay, the portion which is this portion is giving, it is not correct because the working of the electric motor and the diagram does not uh, uh, work together, or you cannot understand the working by this diagram. There is something wrong. Okay, so I'm showing you another diagram, and this is the diagram. This is not the complete diagram. I will show you another components. So this is the diagram of electric motor, and you can see that there are two magnetic pole south and magnetic pole north. Okay, in our book here is north pole and here is south pole. So I will tell, there is no a big difference if we use north pole here, which is negative, or south pole here. Okay, it is not a big deal. So this is electric motor, and this electric motor is made up of, first of all, it is made up of, we have to use magnet. Okay, first of all, we have to use magnet. Second, we are using this thing. What is this thing? This thing, this is copper armature. Okay, this is copper armature, and it is attached with these things. So second thing is copper armature, and this copper armature is like this, and it is attached. You can see this is the 3D diagram. Okay, and when we draw this, there is nothing like 3D. So I'm drawing this. Okay, so this is something splitted. You can see this is a full thing, this is a full ring, and if I cut this ring into two equal half, this is known as split ring. Okay, so this is our split ring. Okay, this is split ring. Okay, I'm telling you the construction. Okay, how the construction works. So this is the complete motor, this is complete electric motor. Okay, in this complete electric motor we are having magnet. Okay, we are having this armature. The armature is this part. Okay, this part, the armature is made up only this part, this ring, and this thing. Okay, this is the armature. Second, armature. And the third part is these black part. You can see this black part. Okay, so these black part are known as brushes, and these black part are Okay, so these black ring, this black part, okay, this is the black part. It is continue. Okay, and so one thing is very clear to you, that and this remaining part is known as brush, carbon brush. Okay, so these are split ring 1 or split ring 2, or you can name them P and Q as our book says. This is P split ring and this is Q split ring. Okay, and they are made up of carbon. This black part is known as carbon brushes. Okay, they are brushes. Okay, not brush, brushes. Okay, and as you can see here, that they are not in complete attachment, or they are just slightly touching. Okay, they are just, there is a slight touch. It is touch. Okay, it is just touch. They are not attached. They are touched, but they are not attached. What does it mean? It means that they are in contact, these brushes. Okay, I name these brushes according to our book, that is, this is X brush and this is Y brush. Okay, so these carbon brushes are, they are black in color and they are just in contact, but they are not attached. So these carbon brushes, or these carbon brushes and this entire part, okay, this entire part is, or if I draw like this, okay, this part is also non-movable. So brushes with battery is non-movable. Okay, and magnet is also non-movable. The only thing which is movable is that armature. Okay, only this thing is movable. Only only this thing is movable. Okay, only this thing is movable. And the non-movable thing is, this is armature, this is movable. And I'm drawing the non-movable part, that is this one. Okay, there is slight touch. Okay, don't think that they are attached, they are slightly touched. Okay, they are slightly touched. Okay, they are not attached. So there is a very negligible gap, or we can say there is very negligible, or you cannot find it with naked eyes. There is a gap, or you can say there is a split. Okay, split, this is splitting, there is a gap. Okay, minute gap, they're just in contact, but they are not attached with each other, they are just in touch with each other. Okay, and in this case these are two magnets, and these two magnets are also non-movable. So this, only this armature part, I want, this, the ring, these are the rings. Okay, and these are the armature part. So this armature part is movable, but these brushes, I'm indicating brushes here with red color, these brushes and these two brushes. Okay, these two brushes and this entire part, it is non-movable. So only the movable part is this ring and the armature which is attached with the ring. So these two rings, split ring. Okay, split, you can see the 3D structure, and these things are movable, another part is not movable. So this is the correct diagram. And you know the mistake the book is making, the big mistake our book is making, that this is the line of armature. Okay, this is the connection, this is our armature. So this armature is actually connected with this ring. Okay, this armature is connected with this ring. In our book there is a mistake, Okay, and the mistake is that they are connected these. Okay, the diagram is wrong, but whatever they wrote that the written thing is that this armature ring is connected with this split ring, and this armature side is connected with this split ring. They are not in connection with these bushes. Okay, but in this case, okay, they wrote correct thing. The correct thing is written in our NCERT book, but the diagram is not correct, as they connected this armature with these bushes. They connected the armature with these bushes, but the incorrect diagram you can see that armature is not connected with the bushes. Armature is connected with the ring. Okay, so this is not a correct part. The correct part should be, why I'm telling you this, because while we study our NCERT we feel confused that what is this. Okay, so it should be connected with these rings. It should be connected with these rings. Okay, not with these brushes. Okay, so these are two, there are two rings. Now I'm so whatever you draw, okay, whatever your teacher tells you, okay, just remember that this diagram is not correct. The armature should be in contact with these two rings. Okay, and these two rings are in contact with these brushes. Okay, so this is they are attached. Here there is attachment, they are particularly attached or jointed. Okay, but here there is just a connection. So we are studying about manufacturing. Okay, how they are manufactured. So there is a contact, no, not contact, they are attached. Okay, there is attachment, they are attached, they are attached. Okay, jointed, they are attached, but the carbon brushes are just in touch. Okay, just in touch, that's why I'm making a bit gap. So they are in touch, but they are completely jointed. Okay, so this diagram is not so much correct. The diagram which is from NCERT, this is our NCERT diagram, and it is not a correct thing. Okay, now I'm moving. This was our construction. So in our construction, one thing is very clear to you, and write correct construction, because this diagram is not correct, but the book tells us the whatever written in our book is correct, but the diagram is not correct. Okay, so just connect it with this. Now it is made up of three things. First thing is magnet. Okay, second thing is this armature. What is this armature? Armature, this is the armature. This whole part is known as armature. Okay, what is the armature? Okay, this is only armature. These are magnets. Okay, south pole and north pole. Okay, this is just armature. You can see only this part, and these are carbon bushes. Okay, these are carbon bushes. They are attached with this battery. Okay, so this is our construction. Okay, and one thing which is movable, only one thing in this whole system or in this whole uh, apparatus, only one thing is moving, and the moving thing is our armature. Only armature is moving. Okay, armature is moving. So whatever yeah, the construction is, it is made up of magnet. Okay, it is made up of armature, and it is made up of carbon brushes. So these are split ring 1, split ring 2, carbon brush X or carbon brush Y. You can name accordingly, whatever A, B, C, D, whatever you name them. Okay, and this is our battery. So in this construction you can see that how the current will flow, and the current will flow from this side to this side. Okay, this is how the current will flow. Okay, and the current will go to First of all, let me tell you one more thing, that we are studying about electric motor. Okay, and this is our motor looks like in real. This is our motor. Have you seen this anywhere? This is our motor. Okay, so this matter, and you can see this is this thing. Okay, this is our that armature. This is the real picture. This is hypothetical picture. We are just making, trying to make you understand. So electric motor, okay, it is present in various appliances like fan, okay, like mixer grinder. It is present in washing machine, okay, or anything rotates when you apply current. Okay, so the real structure is like, as we are applying current, this is positive and this is negative, so the current will flow on, and as the current will flow on, the armature will rotate. Okay, what is the armature? You know, this is only the copper part. You can see the copper, or you can see on the, you know, this is copper part. Okay, you can see easily how it's color copper color. Okay, so how it move. Okay, the only thing in this, this is the metallic thing. Okay, this is metallic thing because these brushes are made up of carbon. Okay, so don't think that carbon is not conductor thing, or it is a non-conductor, though it conducts very less amount of electricity. Okay, so they are carbon brushes. Okay, again you can see the metallic part. This is again metallic part, and this is again metallic part. Okay, so you can see the armature. This is the armature. Okay, so it will move. So how the electricity will move and how the electricity will pass on? So the electricity will pass on like this. Okay, this is the path by which the electricity will pass. Okay, so this is our circuit. Okay, our circuit is cleared. Okay, now by using your left hand thumb rule. Okay, by using your left hand thumb rule. Okay, so in this case we are studying about left hand thumb rule of flaming, of flaming. Okay, and we studied on yesterday that while using left hand thumb rule, we will be provided with two things. What are these two things? First thing is the magnetic field line, and the second thing which will be current. Okay, two things you will be provided with, and you have to find the third thing, which is force. Okay, you need to find the force. Okay, so in this case you can see that how the magnetic field lines flow. The magnetic field lines from the outside of magnet, they will flow from north to south. Okay, and this is the direction of current. So I can draw this with black, so it will be easy for you, or with green. So I'm drawing green lines as the direction of magnetic, or I should use blue, so it will be easy for you to see this. Okay, so this is the direction of magnetic field lines, and this is the direction of current. Okay, because we studied that as it is our magnet, this is our south pole and this is our north pole. So you know that outside from the magnetic field lines move from south to north. Okay, so definitely the magnetic field lines will from south to north. They will move from south to north. Okay, so in this case one thing is very clear to you, that two things are provided, that this is my magnetic field line and this is the direction of current. Okay, for this half part. Okay, for this half part, Okay, for the second part, definitely this is the direction of current. For second part, this is the direction of current, sorry, magnetic field line. This is the direction of magnetic field line from north to south, so the direction of magnetic field line will never change. Okay, but in this case you can see here the current is passing like this, and in this case current will go, and current, you know, the current will move from this terminal to this terminal, positive to negative terminal, so it will go all through this armature. So in this case it will move like this, and by rotating it will again come to this route. Okay, so in this case, in half armature the condition is like this, and in half armature the condition is like this. Okay, because current will come down again. Okay, so just use your left hand thumb rule, and two things are provided to you. One thing is magnetic field line, and second thing is current. We studied this, and one thing we have to find out, that is force. So we have to find out the force. Now what is the force? That if I use this, okay, so this is my current. Okay, so I want to place this, and just try to place this on this diagram. So place this, uh, this is my current. Okay, so I'm using my current. Okay, as you can see this. Okay, do it by yourself. Okay, so this is the direction, this is the direction of, okay, you can see this. Okay, my thumb is again upwards, and my middle fingers is all also upwards. Okay, so just look at this diagram, that, okay, look at this first case. Okay, I'm going to tell you about this case A. Okay, when I'm talking about half armature. So in this case, you can see the current which is indicating by my middle finger. Okay, so current, my middle finger is indicating current. It is upwards direction. You can see the current is in upward direction. You can see the current is in upward direction. And my first finger is telling you about the magnetic field line. So this is the magnetic field line, you can see. Okay, so how is my thumb, and in which direction my thumb is going? My thumb is going again to upwards, or my thumb is again going to the direction which is upward. Okay, so this is upward direction. So this is upwards direction. Okay, so it is upward direction. Okay, use this by yourself. Okay, this is upward direction, upward. Okay, so this is how, this is the direction in first case. What did we study? We studied that in this case, I am going to draw an armature. Okay, this is my armature. Okay, and this is armature attached with split. This is our full armature. Okay, this copper coil. Okay, and these are two brushes. Remember that the brushes are just in contact. Okay, they are not attached. Okay, and we studied that this was my battery. Okay, so the direction of current will, and this is magnet. Okay, so magnetic field line will go from north to south. Okay, and the direction of current will go this side. Okay, okay, so there are two lines this side. This is blue line is magnetic field line, and red line is the direction of current. So by using this, okay, okay, so this is the direction of current. Just place this on this armature, place this on this armature, just place this finger, okay, in this armature, and you can see that the current is like upward, and this is the direction of magnetic field lines, and the thumb is also upward. So this armature will move upwards. You can see here. Okay, this is the direction, this is the direction how armature will move up, because there is a force which is pulling this armature to go upward side. Okay, so first this armature was like this. First this armature was like this. Okay, it was very simple, you can see it was like flat. Okay, and as soon as we passed the current, okay, as soon as we passed the current and magnetic field lines was there. Okay, so what happened exactly, that the armature will lift upwards. Okay, it will lift upwards, so the direction of current, the one thing which is never going to change, and the one thing is the direction of magnetic field lines will be always from negative, from north pole to south pole. So it is shifted towards upward, you can see. Okay, so it was like this. Okay, and it was like this. Okay, it was like this, and it will shift to this. Okay, so it was horizontal, this armature was horizontal, and this armature will tilt on because there is the force of this. Okay, we studied this. Okay, so you can see this will go in the direction of thumb, and thumb is indicating something upwards. Okay, so it will go upwards, and by slight movement it will come to this direction, it will come to this. Okay, by this thing to this armature will go to as this is straight position. Okay, this is straight position. Okay, so I'm going to tell you that in this case the armature will go uplift. Okay, this is uplifted part. Okay, and in final case, okay, this is the armature which was at first condition. Okay, and what happening, Faizan? Are you able to understand? Faizan, tell me, are you able to understand? Are you connected and are you able to understand? Okay, so it was flat, you can see it was flat. Okay, and by the effect of magnetic field line and by the effect of current which is running by this battery, it will move. Okay, to upwards. Okay, it will move upwards and it will move upwards. Okay, so it is moving upward, it is moving upward. Okay, and again it will come to this thing. Okay, this is just, it was like this and it will become this, it was like this or it will become this. Okay, it was like this and it will become this. Okay, so here you can see, again you can see, I want to tell you that how this split ring works. Okay, so these are the real structure of this split ring. You can see how they are splitted. Splitted means they are not in contact with each other, and they are just in touch with these brushes. So at this condition, okay, you can see the split rings are like this, and the armature is connected with them. Okay, but as you can see, okay, the armature you can see as it will go uplift, it will go to uplift. Okay, it will go to uplift, it will come to this condition, and these two split rings, those were like this. Okay, they will come to like this, they will come to like this. Okay, there is a change. Okay, and the brushes will remain same, the brushes will never change. Okay, and in this case the brushes will like this. Okay, so one thing I want to make you very clear or very sure, that in this case these brushes are, you can see the brushes are, okay, so in this case they are like in this condition. Okay, and the brushes are in bit contact, But as these armature will go upward and come into this vertical position, okay, this split ring, you can see the shape of a split ring completely change. And at this time you can see that how the movement of this split ring will break completely the connection with these carbon brushes. Okay, at this time they are just attached. Okay, and as they rotate, as the rings rotate, the brushes will completely lose the connection. Okay, so you can see there is no connection, there is no connection, they will completely rotate. Okay, so in this rotation, okay, you can see one thing I want to tell you. Okay, you can see this gap, you can see this gap. Okay, so as they move, okay, as they tilt or as they rotate, okay, so first of all they are like this. Okay, and these are the carbon brushes. Okay, but as they rotate or they move like this, because as the armature will move, they will also move, so this gap will come to these sides. Okay, as they move, the gap will come to these sides. Okay, this is the gap, this is the gap. Now this gap was as the armature was in horizontal condition, so the gap was in vertical condition. And the armature, when it armature come into horizontal condition, the gap was comes in these horizontal conditions. So this is the gap, and these are two the carbon brushes. So you can see the as they move, the gap will come to this side. Okay, so I am going to show you the gap. So you can see here that gap is also rotating, and in this case, particularly in this case, you can see that at this side there is no gap, at this side there is no gap, and the gap is come to this side, there is a gap and there is a gap, because this gap will also rotate. But this gap will change its position, because the armature is in horizontal condition this time, and this armature is in vertical condition this time because of this force. And the side, okay, as they rotate, so the gap will also rotate. You can see the gap, we can see the gap, this is the gap, this is the gap, because the main reason, okay, this is the gap, this is the gap. Okay, so this gap will also rotate and come to this side, and armature will go to horizontal, sorry, vertical condition. Okay, so at this time, okay, exactly at this time, exactly as the gap will rotate, exactly at this time, okay, this is armature, and now I'm drawing it as horizontal. Okay, sorry, vertical, and it was horizontal before. Okay, so this is the gap is like here. Okay, so at this time when the gap is here, okay, at this time when the gap is here, okay, so because of this gap, because of this gap, okay, because of this gap, okay, the connection will definitely flow. At this time these brushes were in contact with these split ring, these brushes was in contact with this split ring, and this is the flow of current. Okay, but in this case, okay, the current is in continuous motion, but because the split ring get rotated, okay, as the armature get rotated, it will also get rotated. So at this time there is no current, because the gap is come here, the gap, you can see this gap, this was the gap, and this gap, this will, as this will move, okay, this will move, it will come to this condition, and this gap will come to these conditions. Okay, so in this case, okay, this is the fully gap, they are fully gapped, you can see the gap, it is the fully gap. Okay, and in this particular condition when they are fully in, gap will come here, because the main reason of doing all this thing is this split ring is, the split ring, this is broken ring. Okay, so the current will definitely flowing, but is the brushes are not in direct contact. Okay, so current is flowing, but how the current will pass to these things? So how the current brushes are also carrying the current. Okay, brushes are also, they are also carrying the current. Okay, but as there is a gap, okay, the split rings are rotated and there is a gap. Okay, there is no a space. So how current will pass on? How the current will pass on? So at this particular stage, you can see that they are horizontal here and it is vertical here. So at this particular stage, when it is, there is a gap, the blue color is that split ring gap. Okay, there will be finally no electric passage or no electric current. At this time, it will feel only one thing, that is the magnetic field line, and at this time, there is no electric current. So at this time, it was like this and it is now like this. So at this time, there is zero current or zero passage, or finally no current is flowing when this armature is in vertical condition. Okay, so now what would happen? Should it was like this? Okay, and now it was like this. Okay, so I'm denoting this. This was A side, this is B side, this is C side, and this is D side. Okay, and in this case, okay, in this case, this was A side, this was B side, this was C side, and this was D side. Okay, and in this particular case, okay, then in this particular case, this is A side, this is B side, this is C side, and this is D side. Okay, so A side is upside. Okay, so should it go to this side or should it go to this side? That means that in this particular condition or in this particular place, should AB returns to its particular condition as it was like here, or should it go to it this condition? Okay, so where should it go? Okay, so in this case it was A, B, C, D. Okay, and the question was the this is the next condition. Okay, at this condition. So the question is that where should this go? Okay, so this AB should rotate to here, or it should go back to its previous condition. Okay, so either it was like this. Okay, okay, it was like this and it is now this. Okay, it was like this, look the direction of my thumb, it was like this and now it is this. Okay, so should it go back to this condition or should it flip like this? Okay, it was like this before, look at my thumb, it was like this before. Okay, and now it is this condition. So should it go back to original condition or should it rotate like this? Okay, so this is the main thing. Why? So because at this time you can see, because the gap come here, the gap came here, because it is continuously rotating, and we can see the how gap will change its position, or how it as it will rotate. Okay, so the gap, this split ring will rotate, and the split ring rotate in a such a manner that the gap will shift towards this side. Okay, and this armature will be in vertical position. So at this particular position, okay, the question arises at this particular position, because at this particular position it is gap and it is the gap condition. You can see the difference between these split ring, and you can see the difference between these split ring. This split ring, you can see the condition of split ring, that gap is like in this way. Okay, and in this case the gap is in this way. Okay, so it is a rotating thing. Okay, so A was here, B was here, C was here, and D was here. And here, this is our A, this is our B, this is our C, and this is our D. Okay, so should AB move to this condition or should AB move to this condition? Because at this time, remember that there is finally no electric current is passing, because the gap is shifted to here. Okay, this is the main thing. The split ring is main thing. Okay, the main thing of understanding, or the main thing of this motor is this gap. I told you that this split ring is of very much importance, because this split ring will move. As this split ring move, the gap will shift here. Okay, at first it is at this side, and as it move it will to this side, but as same time at this time the armature is also in this condition. Okay, it is in this horizontal, it was like this and this. Okay, now at this time all the connection is broken, because the split ring is okay changed its position. So the question is that this, consider that my thumb is A, so should I it return to previous condition or should it move to this condition, because it have to move. Okay, so now it is at this condition, and this condition there is no electric current. So should it move to this side, okay, or should it move to this side? This is our question, and we will clear this question on tomorrow. Right now I'm finishing my class. Okay.